So, hello everyone. Today we will see in this lecture that is the introduction to system programming. So here we will cover first of all the basics of the system programming. So first of all, here you can see that is the first very basic diagram of this embedded system. So here you can see embedded system means what? It contains the hardware, then software, and then user interfacing is there. Right? So these are the basic three layers of this embedded system. So now here hardware means that you can see, that you can touch, right? This software layer is divided into the two layers, that is the system software and then application software. Right, and then user can interface it, so you cannot interface this hardware without these two layers, right? So now next one, but what is this application software and the system software? So here you can see the different examples of this application software. So computer games, spreadsheet, word processors, databases, internet browser, these are the some applications, or you can say examples of this application software, right? So which are the system software? So operating system, then utilities, these are the system softwares, right? So then hardware. So examples of this hardware are CPU, disk, mouse, printer, etc. Right? So now we will see, you can see here that is one of the important part, that is the operating system, right? So what is this operating system? So the operating system is an interface between the users and the hardware of a computer system. You can see here, right? So it is a system software which may be viewed as an organized collection of software consisting of procedures for operating a computer and providing an environment for execution of program, right? So what are the functions of this system software? That is the first one, that is efficient utilization of computing resources. Second function, you can say that for this operating system, that is the new features in the computer architecture, giving the response to that new features, then new user requirements, right? So now how this operating system can manage these resources, and what are these resources? So for example, memory, processor, file system, then input output devices, these are the resources. And it keeps the track of the status of each resource and decides who will have to have a control over computer resources for how long and when, right? So we can say that operating system controls the computer hardware resources, right? The programs interact with computer hardware with the help of operating system. Now the question is that how to interact with operating system. So first by making a system call, and second by making a system commands. You can easily interact with this operating system, right? So this is the same diagram that we have seen in the previous slide. Now next one, this is the block diagram. So it will help you to understand this whole process. So you can see here, user means us. People are there, they want to use this hardware. But you can see they cannot jump directly to this hardware, and they cannot interact with this hardware without this application software and operating and systems software. Right? We have seen a lot of examples of this application software. So this application software is totally based on your application, or totally based on the user or your problem statement. It is different for different application. But this operating and system software which is related to your hardware and it is installed in the machine. You can use this one for the any application. So what is the definition of this system software? So interface or buffer between the application software and hardware. Yes, you can see in the diagram. It controls the computer hardware and acts as an interface with applications program. Okay. So now next, these are the some types of these computer languages. So there are the three types, that is the low level language, then middle level language and high level language is there. So low level language means what? That is your binary language, machine level language, right? So middle level language, best example is the assembly language where you have used the mnemonics to create the instructions, right? And this high level language means your basic C programming language, then C++, then Java. Okay, so now these are these high level language examples. Now next one, that is the very important, that is the cross development environment. So here you can see that is in this cross development environment they are using the cross compiler. Before going into the detail of this diagram, first of all understand that what is cross compiler. So the cross compiler is a type of compiler, remember it, right? So it creates an executable code for a program other than the one on which the compiler is run. Or we can say that in short, that is the cross compiler runs on a machine X and generates the machine code for the machine Y. Right? So here you can see this is machine X, machine Y, and your cross compiler is running on this machine X to generate the machine code for this machine Y. Okay, so here you can say one example, that is this, suppose this is your Windows machine, this is your Linux machine, and you are compiling the code for, and you are generating the machine code which you are going to use on this Linux environment. Right, this is the best example to understand this cross compile. So now the question is why there is a use of this cross compiler. Yes, the cross compilers are useful for the microcontrollers that do not support an operating system. Very important. So the cross compiler is used to compile for a platform upon which it is not feasible to the compiling. Right? So now this is the very important points related to this cross compiler. Okay, so now next one, that is this simple diagram. This is the flow of the program execution. So suppose you are writing your program in the editor, then this assembler is there. So assembler will, after the means processing or the after the execution, it will form the object files, right? So here linker, what is the job of this linker? It links all the object files. Okay, consider the one program. It is a very big application. You cannot write the whole program of 2000 and 3000 lines at a time. So first of all, good developer sign is that developer divides that into the small different modules, right? And then it forms the object file, and this linker will do the linking of this all the object files and will form one executed file. Okay, here you can see this is one of the converter, that is the object to hex converter, and finally you are getting the hex file for your program, right? So now next one, again this is the simple flow for your suppose C language program. So this is the source code, then that is the input to your compiler. Compiler will form the object file, and that is input to your linker, and finally you are getting the executable file, right? So the now next in this diagram, you can see that is the complete flow. Here all the language processors are used. So first, that is your simple C program. Then suppose some operations are needed to do on this C program, then you can use the preprocessor, right? So this is the expanded source code. Now next, that is the input to your compiler. Compile will compile it. Then assembly code is there. That is input to your assembler. At the output of this assembler, you can form the object code. And here linker job is to link all the object codes and form the executable. So loader will load it and execute it for your program. So this is the whole flow of the program. So now next, in this diagram, you can see that is the complete flow. Here all the language processors are used. So first, that is your simple C program. Then suppose some operations are needed to do on this C program. Then you can use the preprocessor. Right? So this is the expanded source code. Now next, that is the input to your compiler. Compile will compile it. Then assembler code will compile it. Then flow of your execution of program. So now the next we will see that is the software. We know that software is divided into two, that is the system software and the application software. We have seen some examples, but now in this system software, what are the contents? That is translators are there, operating system is there, tools and utilities are there. So what is this translator? Translators means your examples are assemblers, interpreter, then compiler. These are the translators. We have seen the little bit about this operating system, right? Then what is this tools and utilities? That is your editor, linker, loader, debugger. These are the tools and utilities. Now, what are these application software? So it is totally depend on the developer. It is not like that in every machine you should have these application software. These are some examples. And these application softwares are based totally based on your problem statement or the application that you want to develop. So for example, someone needed computational software, then database management software, accountancy software, then information management software for that application development. These are the examples. So we can say that system programming is the activity of programming or coding a system software. Right? The systems programming requires a greater degree of hardware awareness. This is very, very important. When you try to write the program for your system development, at that time you should be aware of your hardware. You should know the each minor point of your hardware. Then only you are able to write a good program for your system. Right? So now next one, that is the here we will cover all these means topics. First we will start with the language processor, then assemblers, and then microprocessor. We will cover these topics in this introduction to system programs. So now next one, that is the language processor. So now language processor means what? So first of all, the language processing activities arise due to the differences between the manner in which the software designer describes the idea concerning the behavior of a software and the manner in which these ideas are implemented in a computer system. Okay, so the designer expresses this idea in terms related to the application domain of the software, and to implement these ideas their description has to be interpreted in terms related to the execution domain. Okay, so here first of all understand that this is your language processor. Input to this one is the source program and output is your target program. This source program is closer to your application domain. Source language should provide the features necessary for expressing an algorithm. And the idea expressed in the source domain must ultimately be interpreted in terms of execution domain of the computer system. Right? So now this is the basic idea. So you can see here that is the two domains are there. One is called as application domain, second one is called as a execution domain. Very important thing you have to observe here, that is the gap between these two domains is called as a semantic gap. So this application domain is related to your specification, then ideas of the your ideas from your, you can say that that is from your client, or the ideas from the your or it is maybe your idea. So now this execution domain is related to the implementation execution of that idea. And if there is a large gap, then obviously it will cause a problem for the development of the system. Right? So the semantic gap between the two domains often implies efforts needed by the translator to convert a program written in source language into machine code. Right? So if the semantic gap is less, then it is easy to write for the translator. But what will happen if the semantic gap is very, very large? Okay, what will happen? What are the consequences? Due to this large semantic gap, the developer need a very large development time. Obviously, it takes a large time, more time to develop for the development. Then efforts required for the development are high. And after the development, we cannot give the guarantee that it is the good quality product or it will give the proper output. So maybe it is a poor quality of software, right? So our aim is to reduce this semantic gap, right? So for that purpose, we have introduced this PL domain. So you can see this PL domain is in between your application domain and execution domain. So now here we have reduced the semantic gap, or we can say that we have divided it into two. So the gap between this application domain and PL domain is called as a semantic gap. And the gap between this PL domain and execution domain is called as a execution gap, right? So the specification gap can be reduced by selecting a programming language which provides the features suited for writing a particular application. Means what? You have introduced this PL domain, but the programming language that you want to use in the development, that is related more means problem oriented is there. So what will happen due to which you can easily reduce this semantic gap, but at the same time you are going to increase this execution gap if your programming language is problem oriented, and we have to avoid this, right? So now here you can see that is the definition of this say specification gap. So it is the semantic gap between the two specifications of the same task. Right, what is the definition of this execution gap? So it is the gap between the semantics of a programs written in different programming language. Why it is called as a different programming language? Because after the execution, your output is a machine code. So you are converting here, that is one of the form of your source code into the machine code. Here that is the translation is there. So that's why it is used as a different programming languages. Okay, so the now next one, these are the definition of this language processor. So language processor is a software which bridges a specification or execution gap, right? So the program form input to the language processor as the source program and to its output as the target program. So the third point related to this language processor is language processes. Languages in which these programs are written are called source language and target language respectively. So source language is related to your source code and target language is related to your target code. Okay. So the now next we will see what are the different types of this language processor. So the first one, your language processor may be the translator. So what do you mean? What do you mean by translator? So translator bridges an execution gap to the machine language of a computer system. So for example, maybe it is assembler or the compiler. Now next one is detranslator. So detranslator bridges the same execution gap as the language translator, but in the reverse direction. Now the third example, that is a preprocessor. So preprocessor is not the converter, just remember it. So the language processor which bridges an execution gap but not a language translator. It cannot convert the one language into other. Only do preprocessing operations. So language migrator bridges the specification gap between the two programming language domains, two PLs. We have seen the one. We have introduced the programming language domain. So suppose there is a need of the two PL domains, then between these two PL domains, the bridge is, we can say that is the migrator is used to reduce the specification gap. So here you can, in this diagram, you can see that either your language processor may be the translator, detranslator, then preprocessor, maybe it is migrator, interpreter. Okay, so that converts the source program into your target program. I hope that you have understood the language process. So now this is the whole diagram. Easily you can see here, that is your suppose source program is there C++. So we have used here preprocessor because we want to convert that into the C program. So here some operations, pre-processing operations we have done on this source code. Then it given to the compiler, compiles it, and we are getting the output. Now next you can see the assembler. Input to this assembler is assembly language program and output is the machine code. Then what will happen? The linker will link all these object files and will form one executable file. The loader will execute that or loaded that executable file, and finally we are getting this our machine language program. So beautifully this diagram explains the use of this language processor in the system development, or we can say in the program development. Right? So we will see, we will understand the difference between this preprocessor and the translator. So preprocessor, here simple C++ program only converted into C program. There is no translation, no conversion. And at the same time, if the errors are occurred also, it will show us that is the what are the errors. Now, but you can see here the role of this translator. Your C++ program is converted into machine language program. Totally translate from one programming language to the other. Right? So these are the best examples to remember the difference between this preprocessor and translator. Okay. So now the interpreters. So you can see, first of all, see, we have started with this application domain and execution domain. Then there is a we introduce this PL domain in between these two. So what is this interpreter domain? This is your interpreter domain. Okay, but what is the use of this interpreter? So this interpreter is useful during the program development, right? A program execution requires either a compiler or interpreter. Right? So what is the compiler do? That is, compiler translate a source program into machine instructions, and these machine instructions are executed by a computer. But in case of an interpreter, the interpreter accepts the source program and performs the actions associated with the instructions. This it creates a virtual execution environment. Just remember it. And the interpreter has the control of the execution of the program during execution. So what the difference between this compiler and interpreter? So first of all, remember that compiler translates the entire program into the machine code, but this interpreter translates the code one line at a time and executes each line as it is translated. And we can say that interpreter reads the source code one instruction or line at a time and convert this line into machine code or some intermediate form or executes it. So now the question is, what is the advantage of this interpreter? Why we are using it? So the advantage of this is it is simple and you can interrupt it while it is running. Change the program and either continue or start it again. But we know that when there are the advantages, at the same time disadvantages are also there. So the disadvantage is that every line has to be translated every time it is executed. And because of this, interpreters tends to be slow, but it is very useful in a program development as the program can be modified online. Just remember it. Right? So here we have seen all the basic concepts of these language processors and system programming. Okay, in the next lecture, we will see what are the activities are there by language processor and what are the fundamentals of the language processor. So we will stop here. Thank you so much.